Hello and welcome to the iSystem Getting Started with Infineon AURIX video series. If your hardware is already connected and you're wondering how to proceed, you're in the right place. Follow this step-by-step tutorial. You will learn how to create a workspace, import source files, and manage your project. First, you will create a new workspace. A sequence of dialogues will guide you through the process. Name your workspace and choose the location, then click Create. Now select your debugger hardware. WinIDEA automatically detects all blue boxes connected via USB and TCP IP communication interfaces. We will use this blue box connected via USB, so we will select it and click Accept. Now define which specific AURIX device you're using in your project. The next step is to specify a symbol file containing debug information. This is usually an ELF file, which often also includes a binary code which is to be programmed. Click here to add it to your project. If you're using a separate binary file for programming, select this option. Click here to add your file. With the device specified and the files added, you can proceed. Create a new workspace by clicking OK. The first thing we have to do is define CPU-specific settings. To do this, go to Debug, Configure Session, and choose the SoCs page. You will see the device you selected earlier listed here. Double-click it to access its settings. As you can see, your device is also already listed here. For detailed explanations about settings in the SoC MCU dialog, press F1 or click the Help button. It will take you to the WinIDEA Help page where you can learn about more advanced features. Depending on the blue box setup, configure an active probe if you're using one. If you're using a debug adapter, for example, the IC501632, you can leave it empty. This Configure button here will take you to the CPU Options dialog. You can configure additional settings there. You can also access this dialog by clicking on Hardware in the main menu and choosing CPU Options. Let's start with the SoC page. Here on the top, you can see the Debug Channel section. Let's change the mode to DAP Wide. DAP Wide is recommended because it provides the highest debug interface bandwidth and works for the majority of AURIX-based embedded targets. The DAP connection supports a 2-pin and a 3-pin protocol. Those pins are called DAP 0, 1, and 2. If your PCB makes all 3 of them available on the connector, use DAP Wide. Otherwise, use DAP Standard. If you are not sure, start with DAP Standard and then try DAP Wide. On the right side, you define the DAP interface clock. It can run up to 160,000 kHz. A faster clock means faster data transfer, which you will mainly notice when using the MCDS trace. In general, be careful with this setting since your circuit board may have a non-optimal PCB layout and cause signal integrity issues. 10 MHz is a good starting point when connecting the blue box to your circuit board for the first time. Once you start using the MCDS trace, try increasing the clock towards 160 MHz in steps. You can specify the debug password here. In most cases, your device will not have a password set, so you can safely ignore this option. However, if you get debug connection issues, one of the things to check with your device supplier is whether the JTAG DAP interface has been password protected. Now let's move to the Reset page, where we will take a look at the multicore synchronization settings. Typically, available cores are not synchronized by default after reset. The way to configure synchronous core operation during debugging is to use an initialization script, which is distributed with WinIDEA. The ini script configures your device in such a way that once one core stops, the other cores stop too. You can find them in the SFR directory. Choose one that matches your AURIX device. Here, you can see the Initialization Before Programming section. Click Initialize and change Script from Default to Custom. We will add a script from the SFR folder. Choose a suitable INI file and click OK. We will also set the same file for initialization before the debug session and for initialization at attach. Check these two boxes, and it's automatically set. In case you want to use a different script, don't check these boxes and add it manually. If you need further explanation of how to use initialization scripts, press F1 and 𝘎𝘵𝘵 help will open. There you can find all the information you need. This option here, Disable Watchdog at Initialization, should remain unchecked, which is also the default setting. When the debugger is connected to the microcontroller, internal watchdog timers are suspended regardless of the application state being either stopped or running. Now let's return back to CPU options. AURIX devices have several delicate modules, BMHDs, HSM UCBs, which can lock the device permanently if they are configured incorrectly. 𝘎𝘵𝘵𝘥 features a security checker which reduces the risk of this catastrophic event. It verifies the UCB content, among a few other things, before the program file is programmed into the program flash. It will reject the programming in case it detects a bad or incomplete configuration. The resulting error programming notification in the progress bar looks like this. Now you are ready to perform a download and start a debug session. This brings us to the end of this episode. You have learned how to create a new workspace and carry out basic configurations. Now you can start debugging. Thank you for watching and see you soon in the next part of the Getting Started with AURIX series.